Welcome to Chemistry with Caroline. In this video, we're going to take a look at different functional groups in organic molecules. So in organic chemistry, almost every molecule is going to be comprised of carbons and hydrogens primarily, but the introduction of other atoms would give us a different functional group. The molecule I've drawn above is a line angle depiction of pentane, and as a generic group, we would call this a hydrocarbon because it's made only of carbons and hydrogens, and specifically because it doesn't have any double bonds or triple bonds, this would be called an alkane. So in this video, we're going to look at how to recognize different functional groups, and as we move through organic chemistry, we'll look at the specific chemistry of those functional groups when other atoms are introduced into our base molecule comprised of carbons and hydrogens. At the beginning of this video, we looked at alkanes and specifically pentane. Here, I've taken that same base structure, but I've added double and triple bonds. When you have a double bond present in your molecule, the functional group is called an alkene, if you just have carbons and hydrogens. And if you have a triple bond, it's called an alkyne. So it's the end of the name that changes. The ene part tells me that there's a double bond. The ine would tell me that there's a triple bond. So here I have a couple examples of a carbon-based molecule. So you've got carbons and hydrogens as the main chain, but on the molecule, there's a different atom. And so when I have an O with an H on it, that functional group is called an alcohol. When I have an N, and I have Nr2 here, R can equal an H or a carbon. So those could be H's on there. It could just be an NH2, or it could have some other alkyl groups on there. This functional group is called an amine. And each of these different types of functional groups will have different reactivities because of the different atoms and their connectivity. We could also have an oxygen that's internal, it's inside a chain, and if there's not an H on it, if there's a carbon on either side of it, then that functional group is called an ether. And the ether has different reactivity than the alcohol does. In the case of the amine, it doesn't matter if the R group is an H or a C, we would still call it an amine. So that's a little bit different than what we see with the alcohol and the ether functional groups. The other functional group that you might encounter is when you have a halogen on a main chain. So the halogen could be F, could be a chlorine, could be a bromine, or an iodine. Generically speaking, this functional group would be called an alkyl halide, and it doesn't matter which one I have on there. There are many functional groups that contain this C double bond O here. And generically speaking, when we have a C double bonded to an oxygen, we call that a carbonyl functionality. Now, what's next door to the carbonyl determines what specific type of functional group it is and the reactivity of it. So if you have at least one H directly attached to the carbon with the carbonyl on it, so the H has to be attached to the carbonyl carbon, that's called an aldehyde. If on either side of the carbonyl carbon there are carbons, then you'd have the second compound, which is generically called a ketone, as a functional group. When the carbonyl carbon is directly attached to an OH, that is a carboxylic acid. And if it's directly attached to chlorine, then it would be called an acid or an acyl chloride. So it is the connectivity directly to that carbonyl carbon that differentiates these functional groups from one another. They all contain the carbonyl, but what's next door, where the green arrow is pointing, is what determines the specific functional group that that compound is. In this last example, I just want to make a distinction about connectivity. So we've talked about this carbonyl compound, and it's this carbon and then what's directly attached to it that determine what type of functional group it is. So in the example on the left, I have a carbonyl C double bond O, and that carbonyl carbon is directly attached to the nitrogen. When it's directly attached like that, the functional group is called an amide. Now on this example, I've got my carbonyl carbon, but directly attached to the carbonyl carbon is not the nitrogen, it's one away. There's a carbon. So this is actually two different functional groups. This is a ketone on the left of the second molecule, and an amine on the right of the second molecule, because they're not directly attached to one another. So one molecule can have multiple functional groups, and the connectivity is what determines what functional group you have. So this has not been a comprehensive look at every functional group, but hopefully this gives you an idea of how to identify a functional group based on the connectivity of the molecule. If you found this video helpful, please like, subscribe, and share with your friends. Thanks.